Thank you for joining us today on this edition of the Fluke series. We value your time and your interest in improving the quality of metrology work throughout the world. We welcome you today for our webinar on end-to-end calibration of pressure sensors. Questions throughout the course of the presentation, please feel free to send them through the Q&A tool inside the web program. Questions to all panelists, and that way both myself and Kyle can see the questions. In the recording, and a copy of the slides will be sent out by email the next 7 days after the presentation. Is Mr. Kyle Clark, support manager for flow calibration products based in the Fluke Calibration Center of Excellence here in Phoenix, Arizona. 1 years in customer support positions. His career Fluke calibration in the former DH Instruments spans 11 years and includes positions in international sales, service, technical support, and training. He teaches the Fluke Calibration Flow School and also the Compass for Pressure School. The presentation will be on end-to-end calibration of pressure sensors. Kyle's going to go in depth into a couple of different examples, and specifically examples using our Compass for Pressure and some of our products. The overall theories he's showing will, of course, be no matter what it is that you're calibrating as a pressure sensor or the software that you use. So without further ado, let me turn it over to Mr. Kyle Clark. Thank you.
And thank you all for attending today. As said, it's end-to-end calibration of pressure sensors. I'll bring up the agenda here. Here's the agenda for today. I have it pretty detailed into Compass with an example, but I'm going to go over pressure calibration basics, a little bit of talk about automating a pressure calibration in general, and then get into the Compass for Pressure calibration software overview and a specific example with screenshots directly from Compass, data file resulting from a run, and a calibration report. And we've done at least one like this in the past, a similar title, and it's still available on our website. It's got the overview and the example of a Fluke pressure module being calibrated, and this one is similar to that, but what I really want to do is get into more details of macros. This will have a quite complex macro in it that really does the same thing or very similar as our cal tool for RPT legacy software, and the cal tool macros feature in Compass. While those features or the voodoo that happens is hidden behind the scenes, this is all in the macros. Even me, software guy, learns to follow along in those with the comments we put in them. So we're going to get detailed into those macros. And check my audio to make it a little bit louder. I'm doing that. This overview. Sometimes I do that. Hopefully it will be a little bit better now. So in those macros, the overview, all is in the slides. There's quite a few. I'm going to glance over some of the slides, give you a little bit of time to read them, and highlight some important points, and then some features of Compass that are quite often overlooked but useful also. Okay, so the is going to be what we call a PM200 module, pressure measurement module, from our 6270A modular pressure controller and calibrator. And these modules can be calibrated in the 6270A chassis, or you can take the module out and put it in what we call a PMM calibration kit. And that has a RS-232 cable connection to a computer. And in the example, I'm going PPC4 to calibrate the PM200 module. Most often use a piston gauge, but the theory is all the same. And you can use the macros to read the calibration coefficients from the module, calculate new coefficients, and do a verification run. And some audio difficulties. Please hold. I don't know what the problem is today. All right, so that's going to be better for everybody. Getting into the basics. What is the pressure calibration? The word comparison is used synonymously. Calibration is applying a known pressure to a pressure measuring device under test. That's what it's called in compass with pressure. Other will call them UUTs or devices, and sometimes we almost refer to it as probably a DUT. In that comparison, we're going to determine the relationship between our reference device and the DUT. We went through a set of points, but the calibration could be a signal where we're really just adjusting any offset. And quite often for pressure, that would be done at barometric or atmospheric pressure. So that's a very convenient point to do that. It's done, but not always, and particularly, it's not always possible with some devices. And make an adjustment, we do a verification whenever possible, and almost in the precision measurement calibration business, we provide a report or data to customers. Okay, so components for pressure calibration. One or more DUTs, reference devices.
Okay, we're still in audio stuff. Switch back to their headset. In just a minute, we're going to try to fix the audio.
I don't know if that's any better. Audio gets any better. Apologize if it's not loud enough or any problems with that. Speak louder. Okay, and we have generation and control hardware. The controller is integrated into the reference pressure device. PPC4 pressure controller is an example of that. And then we have any other necessary measurement or control hardware, including DMMs, power supplies, maybe a multiplexer if we're doing multiple DTs, and you might have ambient temperature, humidity, pressure devices, and really any other auxiliary devices that you would want. And read those, you can send a command to them and get a reply back. Of course, for sure you have interconnect hardware, the fittings, the tubing. We're not going to go over that in this. And Automask, of course, you're going to need software and a computer to run that software on. Okay, and becomes in how much can you automate the test? Typically, that depends on a communications interface for the DUT and your reference. So a manual device like a pressure gauge or a deadweight tester, or a device that has a display but not a communications method, you're going to have to do manually. So type in the values and you're going to be able to fully automate that. Some examples is sometimes you read the DUT, you can't read it directly, like a transmitter or a transducer that output milliamps or volts. So you voltage of that through a DMM, and then perhaps DMM has a communications link that you can connect it to a computer and read it automatically. Case that can be very powerful. A Fluke pressure module is an example of that, where you cannot read it directly. You have to use a 700 PCK kit, which comes with the 700 PCK software to read the Fluke pressure module. And we have a special interface macro in Compass that Compass actually talks to that 700 PCK software behind the scenes to communicate with that pressure module. So Compass is, that macro is using an ActiveX or object-based software to communicate with that other software. So that example that's already in Compass, and there's an example in the Compass macro editor and the example DUT setups of an object-based DUT. So if we can automate the test, there's some benefits to be realized through that. Because obviously the automatic entry of test data without any typographical errors and saving that data. You can run complicated tests overnight, maybe lunch, and running those tests, you can doing some other work. Nice automated tests is you can do complex calculations real time. Like if you have correction factors that you know are used with the DUT in its real application, you can apply those to the device while it's running in Compass. Stands a big benefit, run the same way every time, and have multiple technicians or locations, they can all run the test the same way. And our automation software for pressure calibration is Compass for Pressure. Supports of automation, entry, semi-automated or fully automated. You can do one DUT, and that's limited only by the data acquisition hardware. How many ports your multiplexer has, how many RS-232 ports you can get on a interface box, and have test definitions in Compass, and the data saved in files, one for each DUT, and there's a calibration report tool that you can configure also. Okay, so the steps in configuring Compass to run a test are you set up the DUTs, and if you have piston gauge or deadweight tester, you set that up also. So those are two types of devices in Compass. Any device that is not a DUT or a piston gauge deadweight tester is a support device. And that can be your reference devices, it could be your DMMs, your power supplies, ambient conditioning monitors, temperature devices, and then those set up the test. Now, all of this does take some time, but once you've set up these devices, the work is done, running the test is quite easy, and when you have a new device in the future, you typically start by copying one that's already there. And we also do offer training courses in Phoenix and on-site training for setting up Compass. I'd say at least 10% of customers get some sort of training for Compass. Okay, working up a DUT, and here's an overview, but I have the specific screenshots on the following pages, so we're not going to go into the slide in detail. And many of you might already be familiar with Compass, and the intent of this is to really get into those macros, so I'm not going to cover every point on these slides. In our example here, Header tab, you can see there are tabs in Compass, and our example is going to be that PM200 module, 300 PSI, in our PMM Cal Kit, which we also call a Cal sled. And it is set up as a simple DUT, not an advanced DUT, and really the difference would be is that an advanced DUT can have more than one output. You can use it as an individual device with a unique serial number, or you can set it up as a generic profile device. 100 of the same type of DUT, you don't have to set up all 100 of them in Compass. You could set up a profile, and each time you run the test, you have to enter in the serial number. Wouldn't mention help icon, but the help icon in Compass is context sensitive. So whenever you have a question, click on that, and it's going to get you to the right section in the help file. The Calibration tab, all the cells in here are optional. A nice thing that you can do in here, once you've set up the DUT and the test, you can specify the default test to run so that when the technician is initializing the test, they don't have to choose it. They can change it then, but it's going to populate for them, one less decision they have to make. Okay, Applications tab, you can see the methods that Compass supports. We're going to be S232 with this calibration sled. Same screen, I'm going to go back to it. We have the Edit Commands button. That enter the commands that are going to be used to communicate with the device. Here we have Initialize command that is setting or confirming that the units from the calibrator sled are in PSI, and then we have a read command that is simple VAL question mark to read the pressure, and there's a response section here where you could use a macro. The help file explains this, but it's very powerful all in itself. If your reply, let's say, had 3 comma separated values, and the pressure was after the second comma, if you put 2 commas in here, it's going to skip everything before those first 2 commas. Okay, Put tab, and remember, this is for a simple DUT. This is a little bit different for an advanced DUT. But we have raw output that is typically a pressure, or the raw output can be voltage or milliamps, and then the final output for a DUT in Compass for pressure always has to be pressure. We can support devices that are temperature or our DMM that'll be volt or current, but a DUT's final output is always pressure. Options for setting up the tolerance in Compass, you can see here. And in advanced, you have even more. Okay, the difference with an advanced DUT, you have a summary of the multiple outputs that you've set up, and you can go into the details of the outputs and the commands separately. You can see the output and the final output are actually on separate windows, so you can do a more complex relationship between them. You can do a macro relationship between them. Have the comment tab. Everything in here is optional. Once again, setting up the initial DUTs takes a little time, but once you've done it, you don't have to do it again. Okay, and then let's support devices. And once again, support devices in Compass are any devices that are not a DUT, piston gauge, or dead weight tester. Setting them and the screens are virtually identical to the DUT setups, so I'm not going to go over those. And once again, example today uses the PPC4 pressure controller as the reference device. Okay, overview of setting up a test in Compass. I have shots on the following pages, so we'll go right to that. Okay, we have a pretest tab, and we could pretest macro, make message box to give the user some instructions, open your supply pressure, open a valve, close a valve, turn on a vacuum pump. It supports leak test prior to the test, also an exercise if you like. And the thing about Compass is you don't have to set the units in a test to PSI or millibar or KPA. You could set to %, full scale, and then your test becomes a more generic test that can apply to many DUTs, and you don't get a bunch of different tests that the only difference in them is maybe the pressure unit. This is how to add a macro at any point in a test. This is specifically for pretest macro. Anywhere you can do a macro in a test, you get this drop box and you select the macro that's already there, or at the bottom of the list, it says add edit macro, and that'll get you right into the Compass macro editor tool to edit or generate a new macro. Our pressure tab, mostly what we do on here is type in our set points that we're going to do, and we can specify the devices that we're going to use in the test. If we don't need to choose those when we initialize the test. Device is our reference device. The set device is our controller. And you can hear if you hover the mouse over the set point numbers to the left, it'll turn into a hand, and it gives you the point options list. This is where you would do a macro that's going to run before a point. You could also do a valve driver change to a relay that's most often going to turn a vacuum pump on or off. Could be anything. Okay, and then to the read child tab is what these are called, if they're below the main parent tabs. And this test only has one reference device, so it's just showing my PPC4 here. If I needed another device, I could go to add, and another powerful feature of Compass is even with a single device, I could go into edit and choose the specific QRPT or sensor in this PPC4 that I want to use during this test. And then when the technician initializes the test, they don't have to choose that. It's already chosen for them. Child tab, and here is an example in the test that we're going to do today is we're going to be running in dynamic mode with active control, and so we're going to be concerned with the hold limit. When we set a pressure point of like 300 psi, how close to that point do we have to get before a ready signal? And you're typically set the criteria to 10% of the Dutch tolerance. The limit would be like control noise, and if the control noise is 10% of the Dutch tolerance, it's pretty much considered insignificant. Additional steps to verify that and make sure you do a good test, but this is the quick and easy way to do it. Data tab, and you can see we're going to average. If we hit the lock test setup button, that would prevent a technician from doing the test or the devices when they're initializing the test. And if we make a local test on a networked install, you could only test on this PC. The computer's name is actually saved in the test record. If we want macro, which in this case we are, it is called Payment Module CalSled Master. And we also have a post-test macro for this one. So this macro that makes everything happen with the cal tool type features. Okay, tab is optional, and you would specify any auxiliary devices to use. On all selection screens, the devices up on top are the available devices. Once you click them, they appear down here and will be used in the test. And if you do advanced test and not a simple test, you get the options tab. And what I like about it is you can specify which calibration report template to use. If you own a template, you don't need to do this. But if you have multiple templates, it's helpful to do this. Comment tab, nicer here in the last few versions of Compass is you can hit the select button and choose an actual photo that you've saved to your PC, and it's saved. And then when the technician runs the test, when they're entering it, they can click a button and set actual photo. So if you get a test device in maybe once a year, and it's kind of a complex setup, and you don't remember to set it up, you get that photo. Okay, and you run a test, there's options. By menu path in Compass, you can run a test definition, and that would be running that test that you've set up and selected. Or you can run a manual test. It's as but you're not running a test, and the user would be able to select any points to do, which data to collect. It's particularly useful for logging data, even overnight, at a specified time interval, or shooting some Compass setups or tests. Okay, into initializing the test. This is the first screen, pretty self-explanatory. Then is select our DUT or multiple DUTs. If you double-click a profile DUT above, Compass is going to ask you, okay, how many of these do you want to calibrate? We're only doing one in this example, and it's that PM200-GM300 PSI module. That is to verify or configure the DUT. If it's appropriate, you could actually click on this Customize Output button and change the range of it and tolerance. So again, a way that you don't get tens of DUTs in your DUT setup files, and you can make a generic record if that's the way you want to do it. And selected the test in our DUT screen, it's going to automatically populate here. Another neat test selection window is if you don't remember which test to run, you can actually select the test and then click the View button, and you see those different tabs of the test. And when you're done with it, it returns you right back into here. Wait to the test hardware configuration screen. This would be related with any devices that you specified in your test setup. In the comments section in the test and any devices, the text shows up here in a nice bright way so the technicians notice it. Be some instructions, and then this is where you click the icon to see the picture, and they just show a basic schematic of a calibration sled or the module in the 6270A. And then we can the auxiliary devices. And for any port devices in the test, we're going to go through screens to either configure or verify those. You can see here, it's actually a PPC4, shows PPC3 here. It's auto range to the minimum pressure of our DUT, which is 300 PSI. An application summary screen. Everything looks okay there. We push the finish button. our charts. And starts out with that pre-test, leak test, and exercise. And down here at the bottom left, it says list here, that's where it's at, and it's in the dwell portion of the leak test here, and it's saying that also. At any time in the test, you can click on this red or blue box, and it brings up a small window, shows you what point you're on, and shows you the status of where you're at. This running a test, you can choose a variety of windows to show. The most common would be to show your reference device and then a list of the DUTs. Test, the data grid opens up, and that shows your test points as you're going along in the test. Okay, now I'm going to show you the Compass macro editor. This is a direct screenshot from the Compass macro editor. And even before that leak test and exercise ran, in the macro is at work. This PMM CalSled master that we specified in our test is always in the background, and if conditions in this macro are met, it's going to do whatever's there. This is the master macro because it really calls other macros in it. It knows that it's a test macro, and here's the macro inside the test macros. And what macro actually does is it keeps the measurement mode of the test, which is the mode of the DUT. And if it's in case, it's a DUT and test, so it's going to call this global code macro, which is Fluke CalSled gauge. And that's going to be here up in the global macros. So, and one more thing about macros, anything in green is a comment. Really, you're looking at a macro. So it now has called this Fluke CalSled gauge macro, and let's take a look at that. So it's in the section, here's the name of that, Fluke CalSled gauge, some comments, and it's specifying some dimensional parameters. It sets the calibration coefficients just in the macro to zeros to give that value. But it is going to read those from the PM itself. Okay, and we have if then statement here, and what it's saying, if the current step is 1010, which means the test definition, the data files have been created, then it's going to continue on inside this if loop. And what we do is capture the as found coefficients. And this is just also kind of a help comment, one debug comments. And in a macro, any debug statements you put in are actually visible in a macro spy window that you can activate during the test, and they're logged to a file that's called stat.log. Really helpful for troubleshooting macros, and it can be helpful for saving extra data that you calculated in the macro, but didn't actually save in the data file. Later, you can go back into that and look at it. Continuing on, further down the screen in this same macro, we're going to capture the as found coefficients. Okay, so it's going to do this for every DUT in the test. And here you can see there's a IO send command, and it is reading the offset or C0 value from the module in the CalSled and seeing that to a parameter in Compass called DUT calibration coefficient 1. And reading those to the macro spy and the macro log file also. It's going to do the same for the slope C1 value, and in MacCalTool we have a that's called Z offset. Quite often we've called it an auto value. For gauge pressure device, people would typically call it a tare value, an offset. We're storing what that is also. Okay, and instead of going in shots of everything else that this Mac does, I listed them out here. So it's also read the calibration date from the last cal of the PM module, and it's actually going to zero the reading because this gauge mode module, at the beginning of calibration, we zero it just like somebody would when they're using it. And at the beginning of the test, we're vented, so it's already in a good condition. We call our macro called wait for ready that doesn't like to continue until we get ready condition from our PPC4, actually, from our reference device controller device. One day, it's going to dwell by calling this dwell macro, and it sets the Z offset value to 0. Remember, we've stored the as found offset value, and then it's going to read the current reading when it's vented and store that to a parameter called new offset. For some reason, if it's not applying in PSI or you didn't do your initialize command to PSI, it's going to convert that value to PSI because that's logic further than the macro does. And then it writes offset value to the module to zero it. It did that correctly, and then it saves that to some other unused parameter that's stored in data file, .raw3. It continues through the pressure points in our pressure cycle 1, which is the as found data collection. So it continues. Once it's in the as found data, it calls a global macro called polyfit data, and it sends our reference data to macro, and it sends our raw DUT data to the macros. So we collected our data from the PM module with any actions for existing C0 and C1 coefficients on there. What the macro is, it takes those values and reverts out or strips out the C0 and C1 coefficients. So it's really giving you the raw pressure value from the pressure measurement module, and by sending the reference data and the raw data to this polyfit macro, which is like a linear regression, same as the CalTool software does, that polyfit calculates new C0 and C1 values. And then sends these new values to the pressure measurement module and saves them to the DUT cal coefficient 4 and 5, and those are saved to the data file. So whether you choose to put some saved data on the calibration report or not is up to you, but it can be saved in the data file. And then even that macros by or maxstat log file. Once we've sent those new coefficients to the module, the test continues in pressure cycle 2, which is the verification run. And this is actually made so that it's going to go through all of that verification run data, and if any point error is greater than 50% of the difference, you're going to get a message box. And here's a view of that message box. So, I mean, if you have DUT and you've done a good test, when you've adjusted it, a verification run, your is more than 50%. And the 50% value is easily adjustable in the macro. You could make it 30% or whatever. You could completely comment out this section in the macro if you don't want it to do it. Put a pause in front of the lines to make them comments. continues on, and the test is complete. Now it's sent, and it shows new coefficients to the PM module's memory, but they actually don't get permanently saved there until you send a store command. So it asks you, would you like to activate the calibration? And also note that time in the test, if you're displaying the plot tool when you've been running the test, you're going to be seeing a nice visual display of how your results are. And at this point in the test, I believe your calibration report is already going to be open, so you could click over to that and look at it and determine if you want to store calibration coefficients. If you press, the Mac sends a command to the module to save those new coefficients in the cal date. If you say no, another box is going to pop up telling you that, okay, if you go ahead and cycle the power of the cal sled, it's not going to save those new coefficients. It's going to be like you never ran it. Okay, and this shows you how to activate the macro spy when you're running a test. One of the icons at the top of a Compass run window is device run this icon. Usually tell people it's the black icon with yellow text, and in the drop box it shows show macro spy, and here's a sample macro spy. And actually log these debug statements to the stat.log file. You have to make sure this log to file box is checked. And you can choose to include all macro function calls or not. It shows you whenever it calls the macro, and in addition to the debug statements. So if you only want the debug statements, don't check that box. And slide is an actual screenshot of this stat.log, so you can see it's time stamped, so you could have side by side with your data file and look at each individual point. And you can see stuff is happening fast in the macro. I mean, at this single time in the macro, it's logged all these statements. So this part of it, it's showing us what the new C0 value was, and it saved that to cal coefficient 4. This is the command to send to the offset value. This for the slope adjustment value, the date, and it sent that to it. So these are all saved in the data file. This is also showing you the commands. So you could go back to this if you see something funny in your results, like your calibration report, and maybe understand what went wrong. Okay, the end of the test, our test data, and as it has been running, Compass writes the data to our data file, and the local driver network location. We do have a Compass that at the end of a test, in the Compass report editor template that's basically empty, and put a macro call in there for export to Excel, and actually open your data file or files in a pre-selected and specified in that macro Excel workbook. Good example of this is if you already have a calibration report in Excel that you're very happy with and you want to continue using it, and you get Compass, well, let's populate the data from Compass into another worksheet in that same Excel workbook, and then reference that data in your worksheet to populate it automatically. And Compass would save that unique Excel workbook in the same data file that the Compass data file is in. Very important feature for Compass data files also. So the calibration report editor with the calibration report template and data file can produce a professional quality calibration report. The calibration report from the example. And here a little bit more detail. header section up here, report information, dot information, reference information, showing our as found data, and you can see we set this template up so it shows our as found codes, shows the data here. Notice that there's 2 columns for DUT values. You would use 2 columns for these when your DUT raw output would be voltage. So you could see the voltage here and then the pressure here. In this case, it's redundant. This one, and the tolerance bars are shown in green here around 0. This module in this demo run had a significant offset shift, which you might say, hey, this is a gauge mode module, you zeroed it before. How do you get that? Well, the explanation is this was actually a good module. We had to put a dummy offset into it to make the demo practical as much as we could. As left results, you can see the new coefficients here along with that. And compared to the tolerance bars, the errors as left are very good. Okay, the details about customizing a calibration report, the report editor. Any white is just you can edit it as much as you want. Type it in a different language, use different terminology, and then any in yellow is a data parameter, or it could be a plot, and those are all available in this list over to the left. General information, test data, macros, plots, and you can see the top levels and even the nested ones have plus signs next to them, so these expand out a great deal. Okay, versions of Compass. Of course, there's a demo version available on our website at no charge. This is going to hyperlink directly to it in the slides you receive. For pressure basic, most features are available, and they're enhanced. I'd say out, get enhanced. These are some additional features that you get to do the example that we did today, which has test event macros in it. You would need Compass for pressure enhanced. Assure license is included with either version. You can put additional licenses if you like. You can upgrade to the current version anytime at our website. And if you have an old version of Compass and you need to upgrade, contact us in technical support. Some other features, Compass can actually run a temperature test as part of a pressure test. It's typically done when you're running a temperature characterization on pressure sensors. You ensure that they operate correctly and meet their specifications at various temperatures. So comfortably, you could set up temperature devices and add a temperature cycle to Compass that would control this temperature device and then read temperature from your reference temperature device and from your DUTs. Similar to that, you could do a line pressure test. That is typically with maybe a gas differential pressure sensor. It operates high line pressure, like 1,000 psi. So that would be your line pressure that low side is always at, but you, the high side of it, your plus port, you vary that by low differential pressures. Compass gets that line pressure and your normal pressure cycle with just those low differential pressures, I mean inches of water or millibar, and capture all that data. Compass user levels, passwords protected, network, you can see files that need to be backed up on a network drive. Of resources for the macro editor, it's in VBScript. If you're good at VBScript but don't know what all these terms are in Compass, there is a file from the Compass help file, but I put that in this article here, and sources the internet. Just type in VB script in the search term. I do that all the time. No feature that we used in this test was, imagine if all the macros that we ran in this test, if all that code was in one macro, it would be almost impossible to understand. So it's more understandable by calling global macros or even other test macros from another macro. Compass report measurement uncertainty, there's a macro for that. And that's in version 5, and there's an article about it in our online knowledge base also. Compass support piston gauges and deadweight testers with their metrological values, effective area, true mass values, deadweight flow, and compass gauge calculator, where it solves the pressure equation for the effective area, gravity, temperature variations. Resources, we have application notes, even some videos on our webpage, and this is a hyperlink. And in our online knowledge base, at this link, we have overview, slides, basically, PDFs, and my colleague Daniels actually put together, I think it's 8 videos in there that are sequentially numbered for set up and running a test in Compass and troubleshooting remote communications. Very helpful stuff there. Other reasons, there's example macros included with Compass in the macro editor. We're in the macro editor. You can search for specific terms. And there's 2 help files in Compass, one in the macro editor and one in the regular Compass program. Search those for macro or what you want to do, and you might find another example in there. Or contact in technical support for questions you have. Okay, source, which is coming up very soon, is the 4-day Compass for Pressure training class here in Phoenix, Arizona. You can see the answer here, and here's the link. If you search the site for Compass training, you'll get right to it. And she's coming up very soon. It was a pretty nice time to be in Phoenix. And my Aunt Daniels teaches that course. Okay, well, thank you for your getting through that. We still have some time left, so we'll open it up for some questions.
We have, this goes back to setting up the test setup. Why use ATM or atmosphere instead of 0 PSI? Any specific reason?
But really, I mean, in theory, everything's, in theory, it shouldn't matter if you set that to, not that slide. There's this out seconds. Okay, this is someone asking, why use ATM here instead of 0 for a gauge device? You can see some of the options we have here. Vent system, should all work the same, but whoever wrote this test chose to just make it an atmospheric point. And do that instead of putting a numerical value in there like 0. If you put 0 in, and this was a generic test in absolute mode, it might have problems get down to 0 absolute.
This question is, does the piston gauge calculator interface with a piston gauge monitor, referring to 456, and or LIM?
Yes, a 2456 PG monitor or a autoflow controller or LIM, either independently or connected to either of those, would be set up as a support device in Compass for Pressure, or could be set up as a piston gauge, and by setting up as a piston gauge, compass, that is where you're getting the data, like flow maybe, temperature for the piston gauge. In this, you would have to set up the piston cylinder, the mass set as piston gauge elements in Compass, and with all their logical data, and then Compass would measure from that, and it could be fully automated as you could make the test. Of course, 2465, you have to manually load the masses, so everything in that could be automated.
Okay, the next question is, do you usually adjust zero for absolute pressure sensors prior to taking as found readings?
Zero absolute pressure sensor before test is an option that can be added to a macro. I do know that for some Fluke pressure modules, the absolute ones, we have a map that will do the absolute one. What it basically does is it sets a pressure on your pressure controller, maybe as low as it can go, or to a specified value. It waits until that's stable, and then it takes a reading from your DUT, a reading from your reference device, calculates the error between those, and then applies that to the DUT to correct it. Very much the same way that we did here in gauge mode.
The answer would also say is that if the absolute pressure sensor you're calibrating is zeroed before its usage, then zero it before you calibrate it. If it's not zeroed before its usage, then you should not zero it before you collect your as found data. The as found data should represent how it would be used in normal application. An example of where you would do that zero for its normal usage is, for example, a 7250 with a permanent absolute sensor or a true absolute sensor would be zeroed with the internal vacuum sensor prior to being used in the field, so you would also zero it before you do the calibration. Does this software calculate measurement uncertainties as per international standards, and does the calibration report contain uncertainties?
We do have a macro for that, included in Compass version 5. Test macros, I think the name it starts with UNC, and on our online knowledge base, we also have an article with the text of the macro, and it also, in that article, refers to a Fluke calibration application note for I-17025 uncertainty calculations, and the macro follows along the way that application note calculates uncertainty. S1, S2, all of those, and that application doesn't do guard banding, but we did put a conventional method of guard banding in that macro also. We can edit that also, and the macro uses debug statements extensively, so even your S1, S2 values are logged in the maxstat.log, and then the important values like measurement uncertainty, guard banded tolerance, those are directly saved to the data file, so you can put them on the calibration report. So yes.
Questions. We've now reached the end of our report. We will without a copy of the presentation. We apologize for the issues with the audio earlier. We'll make sure on the recording that the audio is correct on it. Any further questions? Feel free to send them through the tech support email address, or you can send them to myself, the host, Tim Francis, at tim.francis@fluke.com. We'll be sending the follow email that you can use as a certificate stating that you attended this webinar. And also, remember that we have the Compass course coming up here in Phoenix. So if you're interested in getting more information on this topic, you can sign up for that course that's taking place in October. Have a wonderful day.